Please watch the video in high quality. In this video, we will create a C# that add and scale map to real-world measurement, zoom and pan to the mouse position, and orbit the map using mouse and keyboard input. It displays the loading map text while the map is loading, like so. So here we could orbit it around, pan the map, and zoom in and out into it. To use the Mapbox API, we need to create an account if you don't have. So click on, I'll leave the link in the description to this website, and click sign up in the Mapbox. And once you sign out, enter your credentials and create an account. After logging into the Mapbox account, go to create a token if you don't have one, and add a name to the token, anything you would like. And then go down and select create token, and then a new token will be created. Copy that token, and we will need to add it, paste it later to make a request to the Mapbox API. I'll start by creating loading map text, right click, and then UI, and then Text Mesh Pro, and import Text Mesh Pro Essentials. Then I will rename the game object to text underscore map loading. And we'll go to keep its anchor and pivot to the middle as it is, and then just change the X and Y to 0 positions, and the width I'll change it to 300. Then for the text, I'll have it as loading map with 3 dots. And then I'm just gonna keep its color to white and change it to its transparency, sorry, to around 175. I'll just zoom to it to see how it's look like. Okay, and then I'll just do its alignment to be in the middle vertically and horizontally. That's good. And I will change its status to invisible. Next, I will create an empty game object. Create empty. We'll call it focal point, and I will drag the main camera to be. I'll just make sure its position reset to 0, all of it. Okay, and then I'll drag the main camera to be child of the focal point, and select the main camera. Just change its rotation to on the X to 90, on the Y to 180, so that we look down at the plane in a kind of top view. We'll change the Z position to 0 and the Y to something like 20. And then instead of the projection, instead of perspective, I'll change that to orthographic. And the instead of clear flags instead of the skybox, I'll select solid color, and for the color I'll select something grayish. And then the last thing within the camera, I'll change the near from 0.3 to -1000. So we have a space when we're orbiting the map. Next, I'll create a plane game object. That's 3D object under plane, and we'll keep its settings as default. So the position will just reset that to be 0 on everything. Okay, the next step, I'll create scripts. So under the assets, I'll create a new folder. We'll call it scripts, and inside that we'll create 2 scripts. We'll start with one, so create C# script, and we'll call it map control. And once the script is created, I will drag it into the playing game object. I'll just drag it here and select the playing game object to make sure that it is here. So, and I'll double click on the file to open it in Visual Studio. So I've added number of lines inside the map control C# file. And there is, I'll go through them roughly, but there is a link in the description that will go through similar tutorial for the map or similar file in more details. So we start by including the additional namespace, which is the networking system and Text Mesh Pro. And then here we have a number of public variables that to set the that needed for the map box request that we're going to make later. And these two variables are the center, longitude and latitude. You could that's the center of the map you're after, so you could change that to the coordinates that you are interested in. And in my case, I'm just using I think Sydney Town Hall in Sydney. Okay, and then there is a block or a number of private variables that are used to update the map settings and control the maps. And then a number of other variables, private variables, which are kind of replica of the public variables we have over here. And these are to keep the track of the change in the public variables and trigger update when the user change the input of the public variables. Then we could update the map accordingly. Then we have the start method, and in which we measure the distance between the plane to the camera, and then we get the screen resolution. It's a vector 2 that has the data about the width and height of the screen, and then we call the method match plane to screen size. We're gonna go through it now maybe. Okay, so what does this method do is first is get or calculate the plane height scale and the plane width scales to match the aspect ratio and dimension of the screen or the view. And then it transform the game object or scale the game object. In this case, it's the plane that hold the map to match these aspect ratio. And then we get the map width and height in meter to match the dimension of the screen or the view, and we multiply by 10 because the each that's based on the assumption that each unit in Unity it would be equal to 1 meter in real world, and by default the plane, and when it's scaled to 1, that's it contains 10 units on the x and z, so that's the reason for the 10. Then we will set the map and width of that we're gonna send in the request Mapbox request, which is in pixels. So based on the aspect ratio, we set the map width and height, and the maximum value for that it takes a value between 1 to maximum 1280. And so that's this method. We're going to go back to the start. And then we will check if the map or the playing game object, if it doesn't has mesh renderer component, we added one to it, and then we assign material to it here. And then we start a coroutine, we call it get mapbox. And what does the coroutine get mapbox do is get the bounding box, which is the edges or the corners, the four corners, the smallest and the biggest corner of a rectangle that bounding the map, and that's calculated using two methods. One is here, get rectangle minimum to maximum longitude and latitude. What it does, it returns the map bounding box in a form of minimum longitude, minimum latitude. That's the bottom left corner, and the maximum longitude, maximum latitude. That's the top right corner. Using a center, it gets a center, longitude, and latitude, and decimal degrees. In decimal degrees, and the map, the needed width and height, which we determine that is going to match the dimension of the units of the screen size. And this method would call another method to use it, which it's called getPoint longitude and latitude. And what it does, this is based on a Stack Overflow answer, and this is the link to that answer. So that block here is based on that answer. And what it does is return a point in longitude and latitude in decimal degrees using a start point, longitude and latitude, and distance from it in meter, and the bearing, which is the angle that measure clockwise from the north direction. Okay, so now we call these methods to get the bounding box of the map. Then we are ready to construct or create the URL. It is a string, has a default string for the request that we make to the Mapbox, and then we in there we inject our variable in terms of the styles, the bounding box, the values, and the map width in pixel and height in pixel, and the access token. The access token will be it's that you could get from your Mapbox account that we went through at the beginning. And then we make a request www to get the based on that, and we yield the return for that request. And if there is an issue, we debug log that issue, and then we reset the previous these variables to their previous working status. Otherwise, we assign the texture from that request to be the texture of the material of the plane, which is the game object here, which would be the object that holding the map. And then we update the variables, the private variables that keep record of the public variables here. Okay, so after going through this method here in the start, so that is done. Now we go to the update, and this is just number of variables to keep a track of whether the map is loading. So if the map is loading, then we will have the loading text we created earlier in the editor. We set it's active to true, that means it will become visible. And then the game object, the plane, because it's loading, we're just gonna make it invisible by getting its mesh renderer and making a false value, assigning a false value to its enabled, so it's gonna be invisible. And this is just a variable to keep a track on how many frames passed since the last map loaded. And we could set a maximum or minimum frames since maps loaded. I think I set that to 60, but you could set it to whatever is um, makes sense to you. Yeah, here I sent it to 60. Okay, so else if the map is not loading, then we add 1 to the frame since map is loaded, number of frames since map is loaded, and check if it's, so I've decided that I want the map to load and after 60 frame to make it visible, just so that we avoid the flickering in the map. So if it's past 60, then the loading text would be invisible here, and then the get component, the mesh renderer would be enabled to true, so the map would be visible, and then we will reset the frame since map loaded. And then here we are checking if the that's another variable to trigger resetting the map if something goes wrong in here when the request get wrong. So if the map reset is on or true, or if the screen resolution, its width and height change since last time we recorded that, or if the plane distance to the camera change, um, change. So then we will update the plane to camera distance variable, the screen width and height or resolution, and then we call the match plane to screen size method that we went through, and we start the coroutine again to recall the map because the map need to be updated, and then we reset the update map to false. And also else if the reset map is on, or if the user change any of the public variables, then that will trigger another update to the map and so forth and so on. So we went through these all these methods, and well, I'm just gonna go from the start, just scroll down slowly so you could see what's going on. If you need, you will need to write this or follow these script lines. So this is the first block from the top. And then let's say this is the next block over here. And the next block would be the update block over here. And next will be the get Mapbox coroutine block over here. And the next block would be both the match plane to screen size and get rectangle minimum maximum long lat method. And the last block is the get point long lat method. So I'll save the script. Now it's done, and we'll go back to the editor. And now in the editor, because we assigned the script to the plane, we select the plane to see the public variables we need. So this is the access token. I'll need to, and you will need to copy the access token that we created from your Mapbox account earlier and paste it here. So I'm just gonna do that now. So I've added or pasted my access token here, and these you could change the center or longitude and latitude to the area you're after. You could copy these values from Google Maps or any other or Mapbox or any other platform you have access to. And then it needs the loading text, and which would be we just created here under the canvas text map loading. So I'll just drag this here and save. And now we could create the other script to control the zoom and orbit. So right click in the script folder and create C# and we'll call it camera control. And after the script is created, I will drag it into the focal point, which is the parent of our main camera. So I'll drag the script into the focal point and click on the focal point to make sure the script is there, and then double click on it to open it in Visual Studio. So inside the camera control C# script, I added number of lines, including private variables for the rotation speed, for the orbiting, the speed orbiting, and you could change that to a value you're comfortable with, and a variable to hold the mouse hold position for the start, and the zoom scale, zoom minimum and zoom maximum, and you could change those to these are the values that they work for me, but you could change those slightly. And we don't need the start method here. And in the update, first we check if the user click on the left shift and the middle mouse. So this is what I want to trigger the orbit. So I checked if the user clicked in the keyboard the left shift plus the middle mouse, then the cam orbit method would be called. And what it does, the cam orbit, is checking if there is a move of the mouse on both the Y and X axes. If that's happening, then we get the vertical input. using the input get axis for the mouse y, pass it as a string to it to get the mouse vertical movement, and multiply that by the rotation speed and the time dot delta time. And similarly, we get the horizontal input using the mouse x and the rotation speed. And then we transform, which is the focal point, which is at, because it's the game object attached to this script. We transform and rotate it to we for the rotation we need the axis and the angle. So the axis would be the right, and then the vertical input. So the vertical would be around the right, and then we rotate it also around the up axis, which is the y axis, and then we pass the horizontal input, and we also pass the space dot volt so that we could avoid some unwanted or weird behavior when we orbiting. Okay, so that's for the update, and then for the next block in the update, we are checking for the pan. So when the mouse button down, which number 2, when the middle mouse is hold down, is being held down, and uh, and the key, the user is not holding the left mouse, sorry, the left shift key on the keyboard, so it doesn't confuse with that. When the left key is not hold, so that we don't go orbit. When just the middle mouse, when there is a movement in it, then we'll do the pan. First, we'll get the mouse hold position for the start using the camera dot screen to world point, and then we pass the input dot mouse position, and yeah, and then we will check if the input for the middle mouse and the input key, the left shift key is not on the keyboard is not pressed, we will call the pan. And what the pan method does is checking similarly to see if there's a move on the X and Y for the mouse. If there is, then we'll get the mouse hold position difference using the mouse position for the start we calculated here, minus the screen to hold position for the main or the camera. We're using the mouse position to it as input, and then we transform position to we add to it the mouse hold different position difference here we got here. And lastly, in the update, we check we call the zoom while getting the scroll wheel axis input, which is the middle mouse or the scroll wheel on the mouse. And so the zoom method will get this value of the zoom difference, which is the value of the wheel scroll of the mouse. And if that scroll is not 0, then we'll get the mouse hold position start, similarly using the camera screen to hold position. And then we we set the orthographic size of the camera. We clamp the value to a value of the orthographic size, the current orthographic size, minus the zoom difference multiplied by the zoom scale, and the two values that this value the result gonna clamp to is the zoom minimum and zoom maximum that we set earlier here. So the minimum would be 0.5, the maximum would be 1000. No further zoom in and out would be more than that or less than that these values. And then we get the mouse world position difference. Similarly, that's the mouse world position start minus the camera screen to world point and passing the input mouse position to it. And then we transform the position of the focal point that is the parent of the camera. So here we get we change it or set its position and we add to it the mouse world position difference. So I'll go from the start. This is the first block up to here in case you need to follow these lines, and then this is the second or last block. So now I will save and go back to the editor. So in the editor, if I click on the focal point, the script is there. I think there is an error, cannot be loaded. Camera control. I think I made a mistake, a spelling mistake here. R control. If I save and go back to the editor, I think that would pass right. Yeah. Now if I click play, the map is loading. I'll just change the aspect to full HD. And if I zoom out, the map is loading and it's zooming out correctly, and I could orbit. I'm using the mouse scroll to zoom out and in, and shift and middle mouse to orbit around the map, and also I could pan using the middle mouse and again zoom in and out on and both the zoom in and out and the pan would follow the mouse position, as you could see. But that's just the way I like the UI to what I like to trigger, I mean the mouse buttons and the keyboard to trigger my orbit and zoom in and out and the pan. But if you would like something else to trigger these functions, you could just change the input here to whatever you like. So that's it. Thank you. Please like, subscribe, and click the notifications button to help me make more videos like this.